Hi, I'm Grillinator, and I'm one of the researchers and producers of the Grillinator.
I'm Neil Sweeney.
And I'm Sam Gavin. One of our main problems that we did discuss as an idea for an innovation/invention was that when you go camping, current devices make it rather difficult for you to A, avoid food poisoning, B, avoid burning yourself, and C, getting food cooked properly is because you'll either burn it or undercook it, causing foodborne illnesses.
And for past solutions, we did a patent search on the official US patent site, and the majority of the patents that we found for grills were either cosmetic or had absolutely nothing to do with the problems that we were attempting to solve.
This is the research that we did on.
Okay, so this is just statistics on foodborne illnesses and what different sources they're caused by. The meats are at the top, as well as seafood underneath that. Dairy and eggs, followed by the fruits, vegetables, and other such. And the fruits and vegetables are so high because if you're cooking raw meat, and then, so if you're cutting it and it's contaminated, and then you don't wash your cutting board and knife afterwards, and then you cut vegetables and fruits and don't cook them, they would be contaminated with the foodborne illnesses, and then you could get sick from those. And then,
This is food poisoning statistics that we looked at on the Center of Disease Control, and 1 in 6 Americans, 48 million people, get sick from foodborne illnesses every year. 128,000 of these cases were hospitalized. From these numbers, 3,000 died. And I don't know if you can see this on the chart here. 7% of food poisoning cases are a result of camping. And if you take into consideration how many people actually go camping per year, it's actually a good amount of people who get food poisoning.
Our potential designs were 3 different designs. One was a spindle-mounted round grill grate that, after materials choices, it ended up to be a little bit too flimsy to actually function properly. The one in the middle is another tripod-mounted structure. One of the problems with it is it would be really heavy, and they're relatively small because you have to mount the grill higher up on the tripod, so you have less surface area to work with. And the one on the far left is the square table, which is the design we ended up going with in the end, provided both the most stability and surface area.
these are different specifications of the essential requirements. Safety and legal issues, of course, were very high, as well as having the technology needed to actually produce the prototype.
The higher importance of the information that we collected was size and weight. It would be a 36 by 36 inch grate, up to 24 inches in height, and the legs would be retractable, so you can choose what kind of size of length you want for height. And then consumer needs: adjustable grill to allow for over the fire pit or log fire.
Of medium importance, the operating environment. We want to be able to use in many different environments. So if you were camping on a mountain, you'd be able to use it at your campsite, or if you decided to just use it as a backyard cookout. And for the global environment, we didn't want to use any toxic materials, and you wanted to be able to recycle it once its useful life had ended.
Our lower importance would be durability and maintenance. Durable, but should be seasoned once a year. For those who don't know what seasoning camping equipment means, it's if you have a cast iron or a steel piece of camping equipment, you need to rub it down with oil every once in a while to avoid rusting and contamination. And the materials we originally planned to use were a stainless steel grate and galvanized steel supports.
This is our decision matrix. So for specifications, the size and weight as well as the customer needs, they were given a weight of 5 because those are the most important to us. And then the operating environment and the materials, those are given a weight of 3. And then with a weight of 1, the global environment and the operation environment.
The materials we ended up going with and using because we could get a hold of them easier for less money and were easier to work with in terms of construction ended up being cold rolled steel for the frame and the grate structure itself, galvanized electrical conduit for the legs and the supports of the structure, and a little bit of cast iron and brass for mounts and attachments.
Design availability materials will last a very long time, so you could use it up to probably about 5 years before you would need to get it checked or repaired. Bearing the load should be not a problem because we tested it multiple times to find out the ideal weight that could be used for this product, which turned out to be 45 pounds, roughly. Rusting if not properly stored and maintained, so basically you just make sure you wash it after use and clean it every few years before you go camping. It will not mount under heat. When we were welding it in the welding lab, it only burned up to 6,000 degrees, so a standard campfire is about 700 degrees, so you should be fine. And it can be salvaged after use, so you can donate to a junkyard or to a college, like if they need spare steel materials.
These are photos from the welding laboratory that we used. Essentially, the welding process itself for the entire frame took us about 4 to 5 days and used minimal help from outside sources. The only things we really utilized others for would be Mr. G, who did help us with learning the better techniques and how to properly set and store the equipment. And the welding process itself is actually, I don't want to say it's too simple, but it's also not easy. You always got to maintain proper safety, and it is a very well-known and well-used technology today, so it's pretty common and available. Safety is your main concern because it's a high voltage, high temperature, you risk burning or electrocution. So as long as you follow your proper safety procedures and you know what you're doing and you do it properly, the final product should last a long time and you won't get hurt while making it.
And these are pictures of a finished project. On the left, you can see our finished assembly that we made in Inventor. And then on the right, you can see it outside, just in some mulch, standing up. And this is just a picture of just the grate that we made. We used about 65 of those thin rods to create it, and those were all hand molded. And then this is the frame we were trying to hammer it, so it wasn't quite so warped.
Yeah, warping is something that can occur after the welding process, actually as shown on the next slide. Basically, if you do not quench the metal fast enough after you have welded it, the metal remains at a very high temperature, and it takes a long time for that heat to dissipate. Well, if that metal is resting on another piece of metal or some other surface, the heat drains away from that surface quicker than it would from the stuff that's on the side that has the air. The warm stuff will continue to expand, whereas the stuff that's cooling down quicker will contract and harden. So it will cause warping, which can lead to some serious problems. You'll see an example of what we had to do after the welding on our finished product, where I had to cut out one of the corners and re-weld it because the product had warped.
This is our pole or leg that we use. It's a conduit that we have used a custom pin that we ordered from Menards. We have 2 holes drilled in here and here, so you can extend the leg to a different height, depending on how high or low you want the frame to be when you drill over the fire.
Then for our testing, and so as you can see on the left, that is just simulated fire. But as we mentioned earlier, to actually weld it, we had to get 6,000 degrees, and an average campfire is 700 degrees, so it's not going to melt during use. Then on the right, you can see that we did load test it with about 20 pounds, which it held up very easily.
Our testing procedures, we placed the grate under load for 10 minutes each. We tested loads of 5, 10, 15, and 20 pounds. We then checked to see if there was any bends or in the grate. And then as we stated previously, we couldn't test the grill on an open fire because of safety reasons. However, it took 6,000 degrees Fahrenheit to weld it, and average campfire is again 700 degrees.
Possible for future improvements that we were unfortunately unable to do, but were in our original designs due to time and material constraints, was that insulated handles along the edges of the frame would definitely be a feature in the future. The grate being foldable and possibly smaller, because we ended up building it and it ended up being way larger than we had initially thought. I went based on dimensions of a normal campfire pit that you would find at any like KOA campsite, and it's a 36-inch diameter. But if you took it down to 25 by 25, it would actually have a cross section of over 36 inches. So you would be able to fit a 25 by 25 instead of a 40 by 40 like we used. And then an insulated cover, just so that in the future, if you wanted to, you were cooking it, then everybody gets their food plated up, that you could actually put this cover over the top with the grate and use the structure as a table to eat off of.
These are just our acknowledgements. So we want to thank Project Lead the Way for having the program, and then Technology Center page, as well as our teacher, Mark Lindberg, and also the welding and HVAC facilities for allowing us to use their materials. And we also did going to auto tech to do some of the welding when the welding teacher was absent. Then we also want to thank Menards and Metal Supermarkets, as that is where we bought all of our materials. So we also want to thank them for their assistance, cooperation, and guidance in the development and production of this project.
Thanks, gentlemen, for your presentation. Got a couple of questions. So your problem statement was trying to prevent foodborne illnesses from undercooked food. Did you do any testing of your prototype cooking food, checking temperature, that sort of thing? And when you say 7% of the illness comes from camping, is it from undercooked food from camping or other things that happen during camping?
That 7% is actually from just from undercooked food. There actually is more of cases where it's from eating a raw vegetable or something like that, where we just came in contact with the meat. But the reason we were not able to light a fire and do actual cooking testing is because they wouldn't let us light a fire anywhere around on the premises. Yeah. It's school, can't light a fire anywhere. However, that's one of the reasons that we did design the adjustable height and the fact that it can sit on top of the standard campfire pit, because you can have that height to your advantage. If you want to build your fire a little bit lower, you can lower the grill down and use the lower heat.
Hi guys, I'd like to thank you again for a great presentation. My big question is when you're manufacturing it. First of all, good job learning how to weld it. Second of all, are you thinking of tolerances and in particular the outside dimensions of your grate and the inside dimensions of your tabletop?
Yes, we were. Fortunately, there were some complications with the process, including some of the rods that actually melted through and sheared off, so the length was kind of mishandled. However, we did think the outside edge of the grate being 36 by 35 and a half and the original designs, and then the inside the frame itself being 36 and a half by 36 with an inside lift, a whole boot.
So, you built your prototype in the lab. Did you give any thought to, if you wanted to manufacture this on a wider scale, what sort of techniques you would use? Welding-wise, fabrication?
Not particularly. I mean, I know there are robots that do welding in factories on assembly lines, so you could have it tap one thing, move on to the next. But that's pretty much the extent of it.
So, and then are you planning on, would you envision this being mass produced, or is this going to be open source? You put the plans on the internet and people can build their own? Any thoughts to that?
We would try and patent it ourselves and get companies to try and buy it out, so then we would share some of the profits and patent some of it. And try and work with those companies to further develop our ideas into smaller or better things.
Thank you.
Thank you, gentlemen, good job.
Are you good?
I don't know about you, when I saw the Grillinator, I was thinking like Ravinia table, like, right, right to Ravinia. Okay, our next group is group 2, and they have the versatile lift table.